Given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. A leaf node is a node with no children. So these are our leaf nodes in this. So we're going to go from in this story we're going to go all the way down to the leaf nodes and see which one of them adds up to the target path. So this one we can say is true because we have one that adds up to 22, and in this one we're given 5, and none of them add up to 5, so we get false. And here this one is empty when we're given target sum 0, so we get false. So we keep all these base cases in mind when we're solving these. So let's look at our time and space complexity. Time complexity. Or of n. Our time complexity is O of n because each node will be visited once. So our space complexity will be O of log n in the best case, in the best case. Such balanced 3, and then O of n skewed slash worst slash unbalanced 3. So now let's look at how we're going to solve it. We're going to solve this recursively. Solve this recursively with depth first search DFS. So we can solve this recursive. So let's look at our base cases that we need to add it to this. So base case number one, or base case number one will be if we don't have a root. So if root is none, return none. And then base case number 2 will be the checking of our values. Check our leaf node value to see if it adds up to our target sum. And then that will be if. So the way to tell if you have a float node is if it doesn't have a left or right child. So if left dot root dot left is none and root dot right is none, return. So we'll compare the two values. So it's root, the value of the root is equals to our target sum. So now, if it doesn't match this. Once we calm down, we have to subtract. We, if it doesn't, then we'll subtract. So subtract from subtract root dot val from target sum as we go down each path. Go down our path. So when we're going down our path, it will be target will now be sum will now equals to our minus so root dot val. So now let's recursively call on our, let's assign these variables sub3 equals to left sub3 equals to sub dot, let's call on the function. Let me comment this. Recursive call. So sub dot hash path sum, and then put in our root dot left for our root, and then let's go again, and then our target sum variable. This is the same process with sub3 because it's sub dot hash path sum root dot right target sum. Let's return our left sub3 or right sub3. So we'll get true or false depending on if any of them do have a matching one. So if any, the left or the right has it, then we get true. If none of them have it, then we get false. I'll put this comment so we can see. Otherwise, return false. So let's check to see if we have anything that needs to be fixed. Okay, that should work perfectly. Let's see if it does. Boom, and it's been able to pass all 3 cases. And let's submit and see if it's going to pass all cases. And it's been able to pass all cases. So this is it for this, and our time complexity is O(n). Each node will be visited as long as. So, and our space complexity is log n. For the best case, a balance 3, and in skill 3 it will be O(n). And that's it for this problem.